So, dear learners, today let us discuss something about functions. How do functions contribute in developing a computer program? Here, we are taking as a reference the C language for learning functions in C. Functions are basically of two types: system-defined function and user-defined function. So, let us directly go to an editor for which it will be better to discuss these things. So, here is the Dev C++ 5.11 version of an editor where C and C++ programs can be done. Here we are taking prime number program as the reference for the whole discussion today. So it's a simple comment line indicating that it is a program on prime number. So as usual we have the header file. Then this part is called, this highlighted part is called the function prototype. Mind it, this highlighted part is known as the function prototype. Then function has a calling part also. This is the function calling. This highlight. This is the function calling part. Okay. We have been identified which the first part. What was the function prototype or function declaration. This highlighted part is function calling. Then this entire part is called the function definition. So basically this entire function is having three parts, three distinct parts. One is function prototype, one is function calling, and one is function definition. But if we work on system-defined functions, this is all about user-defined function. But if we learn about system-defined function, what happens is the system-defined function, this particular part, this function definition is not to be done by ourselves, because that function definition part is already there within systems library, within the header files. So we need to know only the way how the function is to be called, and we have to know very well about this prototype, because the prototype indicates the type of data type that the function is going to return, then the name of the function itself, and then the parameter that will go inside. Parameters may not go also, but if parameter is there, that means if it is a parameterized function, then some parameter will be there. There is only one integer, so only one int. If another's are there, then there will be comma in another integer, again comma, another integer, like this. So here in prime number program, if we think that this function entire definition part is there within the library of the system library. If we think that is prime is a function that is already there in the function, then we need not to write this. Then our program will be only this much. Only this much of length. Our program will be only this much of length. So what is happening here? A number is declared, then a variable is declared. That means then the number is collected, enter the number, scanf %d ampersand number. Then what happens here? There is a if clause, if control C. This statement sees whether the outcome is 1 or 0. If the outcome of the entire function calling gives us 1, then immediately the printf function, this number is a prime number. this part. This number is a prime part will be executed. If this function fails, that means the return of this entire calling gives us a 0, then else part will be executed and the message called this number is not a prime number will come on monitor. Okay. So now the thing is that how this is prime works. How this is prime works. Let us see how is prime. Now, is prime is the function calling. In function calling part, we are sending one parameter nu and num. So that num part is known as the actual parameter. This num part is known as the actual parameter. Now this actual parameter will flow towards this definition. This definition. This area is actually responsible for the checking of a number whether it is prime or not. Now the num, num comes here and the parameter here. The name of the parameter is to be given here. The name of the parameter is written as small n. So this small n will take the responsibility of that num. That means from now onwards, wherever we get num, this n, this n, this n, this n, all these n's are nothing but this. Okay, that means accents of data. Actual data is carried by num and the formalities are observed by small n. Because this is a area, the name of the function here is isPrime. So isPrime is the name of the function and the name of the function is exactly called here as like isPrime. The function will return one integer as it was told in the function prototype area. Then it needs one integer as promised. This integer is sent like this with the name. The name is not actually necessary, only the type is necessary. But during definition, we must have an agent. We must have a name for the particular integer or particular data, whatever. It may be float also. It may be character also. But here in our case, it is int. So now the program starts. The integer one local variable I is needed here, I equal to 2. So if the I value, that means 2 is less than or equal to n minus 1. Suppose we are finding whether 7 is a prime number or not. So the value 7 is put here in num. The value 7 is sent to the function isPrime. isPrime with the help of this isPrime function, the num goes to n. Num flows to n actually. So n becomes that 7. So 7 minus 1, 6. It starts from 2. So number of loops it will. How many while iteration? That means how many iterations will be here? From 2 to 7 minus 1 it is 6. So 2, 3, 4, 5, 6. That means 5 times this loop will use. That means I is 1, I equal to 1 and I equal to 7 is not of concern for prime number, because any prime number is divisible by 1 and the prime number is also divisible by itself. So 1 and the number itself is not of our concern. That is why I value is started from 2 and I value will go up to 1 less than the number. That means 2, 3, 4, 5, 6. So for 2, this first iteration 2 will be checked. 2 is taken a reminder which n value. What is the n value? 7. 7 is when divided by 2. The remaining part is 0. No, because when 7 is divided by 2, there is a remaining 1. So 1 is not equal to 0. So break statement will not be executed here. So I will be taken one increment. So I value will be now 3. Now 3. Then what will happen again? So 3 is less than equal to 6. It is again true. So n, what was n? N is fixed. We have not given any different any modification in n. So n is 7. Originally it is 7 till now also. So n divided by 3. Again it is not equal to 0 because 3 2s are 6, remains 1. So it is, the break is yet not executed till. So I will become I plus plus. That means I plus plus can be written as, I am writing something like this, I equal to I plus 1. This can be written like this. Sorry, the small I. So I plus plus and I equal to I plus 1. That's it. Now when this entire while loop will finish, what will happen? That I value will reach up to 6, say 7. Then 7 less than equal to 6, it is a violation. 7 can never be less, can never be equal to 6. So while loop will terminate. That means I is 7, n is originally 7. So if 7 equal to 7, return 1, that means 1 will come as a return result of the whole segment. And this 1 will be returned and it will go to this area. This area. So if we will get a 1, so printf will be executed, else part will be rejected. But if we take as an example that we are testing 5. So when we will be testing 5 as the number here, what will happen? Definitely this number is not a prime. It should come up because 5 is not a prime number. Sorry, not 5. We suppose 4. Suppose n is number value is 4. So when it will be 4, what will happen? Definitely 4 will be a non-prime number. So that 4 will come here. Is it? Then it will go down. Now I value 2, it will be 3 will be the termination. So for 2 it will move, for 3 it will move. When for 2 it will move, 2 remainder by 2 equals 0, it is okay, then break, it will come out. It will come out of the whole loop. That means I will never reach to the 4. So I will terminate in 2. So 2 is never equal to 4. So return 0 will come. So when return 0 will come, this is prime will give us a 0, and accordingly this function, this particular printf will be rejected and this printf will be accepted. This printf will be printed on this value. This number is not a prime will come out from the monitor. Okay. So this is how a function works. Okay, in my later videos I will try to give you more insight to the function again. So I am repeating a final thing. This is the int is prime, this is the function prototype, this is the function calling part, and this whole thing, sorry, this whole thing, again sorry, this whole thing is our the function definition. Okay, thank you for today.